Hi everyone, welcome back to this second project of this series where I'm covering the 7 real-world projects that you can do after you have done your certification so that you can build on top of that certifications and then gain some real-world hands-on experience. So in the previous project, we took a look at how you can configure a highly scalable global application using Google Compute Engine, then load balancers, DNS, manage instance groups, and how you can scale it. And then we also looked at if we increase the traffic, then how it behaves. And if we bring down instance, then how does the traffic distributed to other nodes, etc. So that was a fun project. But as promised, now we are on the second project, and in this project we are going to replicate whatever we did in the first project with Terraform. So here things are getting more exciting because we will not do general ClickOps things and then we will go ahead and then create a network, create some subnetworks, firewalls, instance templates, instance groups, load balancers, A records, and health checks, etc. Right? So it's a lot of pain, and I think the last video it took us close to 40 minutes to finish it, right? But here it'll take a lot less than that, and I'll just walk you through the entire code that I have written for the infrastructure as code. And in this case, I'm using Terraform, but you can use any other thing that if you would like to. But I think Terraform is the standard for infrastructure as code and automating the provisioning of infrastructure. So that's what we are going to cover here. So this is what a simple architecture diagram that we came up with last time, and we created these resources, and we will try to create everything here with Terraform today. Now, I'm making some assumptions here. When I wrote this article, I said that okay, you have done your certification, and then you can do everything here to gain some real world experience, right? So I'm assuming that you have already grasped the basics of Terraform, like what are modules, what are resources, how to apply something, how to plan, how to dry run, etc. Right? So that's what I'm assuming here, and you're already familiar with the basic commands, the basic the constructs of Terraform, how to write and use variables, what are providers, what are variables, backends, how to maintain the state, etc. So I am assuming that you have idea of all those things, all the basics. If not, then I will highly recommend to do some quick crash course on Terraform and then watch this video. But if you are still interested to see the end goal and how Terraform enables something, then feel free to watch this. But some of the things might not make sense if you don't have your basics covered. But let's go ahead and then get started. How I will cover this video is I will first walk you through the code, apply it, then we will see the resources in the Google Cloud Console. And if you have watched my previous video, I am using Google Cloud for all these 7 projects that I'm listing that I have listed here. And I've already created the one with Argo CD, so you can watch this particular playlist if you want during the entire week, because for me it takes 1 week to come up with a new video. But if you are done with this first project and then now the second project and you're getting bored and want to just quickly watch the other videos, then you can consider watching the 6th one in this particular series, right? But without further ado, let's get started with our second project and let's dive right into it. So this is what the code looks like, and let me zoom in a little bit. So basically, if you have watched the previous video, we created a network, subnetwork, then firewalls, then we created the instance template, then the instance manager based on the instance template, then health check, then the load balancer, and we did a lot of configuration in the load balancer, like the front end rules, the proxy, we attached some certificates because it was an HTTPS load balancer. Then we did backend configurations, we attached some the managed instance groups to the backend, and then we saw the certificate took some time to provision, and then we hit the load to that A record that we configured for this entire application. So that's what we are going to take a look here. Now I'll skip one part, which is I'll not delete things, I'll not do the load test or performance testing that we did last time, because the behavior will be same, right? It's just that I'm creating everything through Terraform now. So let's start with the module section first. So basically, I have not used any publicly available open source modules here, but you can do that. You can find modules available for basically all the resources. So if I quickly come here and then go to, for example, if I search for load balancer module, Google Cloud, so you can find this one, right? And then you can use this particular module. But what I wanted to do was I just wanted to make sure that you understand what are the parameters that I am setting, etc., so that you get a better understanding. And in future, if you want to make your module rather than using the default one provided by Google Cloud, you can build your own as well. But if you want to get started quickly, you can just go here, read the documentation, see what inputs it is accepting and what outputs it is giving back, and how to use it. You can find a lot of examples here. So I've not used the publicly available modules, but if I quickly go to each of the modules, you'll see there's a main file and then there's a variable file. So if I start with the simplest one, which is firewalls. So last time we saw that I opened some firewalls for SSH, for RDP, right? So that's what I'm doing here. So basically I'm using a Google Compute Firewall resource. I've named it HTTP server, and then I'm opening these two ports and I'm saying, okay, whenever traffic comes from through the internet on port 443 and 80, allow it, right? And this is the network, this is the project ID that I'm taking it as a variable here. So all the variables are defined here, and then they are being used in all these resources. So similarly, I'm opening a bunch of other firewalls for port 22 because I was testing, and then maybe I will try to log in so that to see whether the installation has happened properly or not of my application. And then I'm making sure that ICMP is allowed, all the other ports from 0 to 65535 are allowed, and then the last one is to allow egress so that traffic can reach outside to download something, right? So this is for the firewall. Now next one is instance template. Now if you haven't watched the last video, instance template is a template which we will use to create our managed instance groups. So it's a very simple one where we define the machine type, the project ID, tags if any, and then the disk that we need, the network, the startup script. This is important one, and I'll show you the startup script that I've written in this template file in a short moment. But I'm using the startup script, the scheduling, and the service account. All right, so very simple, the thing that we did last time. If I quickly go to my Google Cloud Console, I can quickly show you the last time that we did. I have not deleted those resources, just for reference point of view. But if I go here and if I go to my instance group that I created last time, and I was using the Star Wars theme. So here, these are the instance group that I created based on this particular instance template. And it was like a global instance template. I chose E2 micro. This was the network name, Death Star. This was the image that I used, and bunch of other configuration, the service account, etc. And this was my startup script. So I did it using ClickOps here. So I went to instance templates and then I created the instance template from over here. Now I'm doing the same thing, but this time I have coded it, and you can use this as many times as you want because it's a module, and module is just a repeatable thing that you can code, and so that you can use it again and again. But I'll not go through this one, but hope this is clear. And then I have an output section, and here I'm just making sure that I output the ID of the instance template so that I can use it in the instance group. So now instance template is done. And now I'll go to the managed instance group, and then I'll cover the load balancer and the storage bucket. So managed instance group uses the instance template that I used earlier, and here you can see that this is the instance template that I'm using, and I've the application will run on port 80. I've defined a name port, the instance name, and then auto healing policies, update policies, and a bunch of other configurations like the auto scaling. So this is one thing that we did last time, where the auto scaling that I kept was the load balancer auto scaling. But here, as you can see that, I'm using CPU target utilization in this case. So you can use other auto scaling settings as well. So if I go here and show you, so last time we used load balancer auto scaling, so that whenever, last time we took example of 80% and RPS request per second of 100. So whenever there are more than 80 requests per second, then, the auto scaling was triggering, as you can see here, right? But this time I'm just using simple CPU utilization, so that's a difference. But I just wanted to show that other option as well to you. But you can control that setting. So if I quickly go here and go to my instance groups, and let me show you the TIE Fighter Asia South 2, and let's go to the edit tab here, and let's go to the auto scaling section. So here we are saying add and remove instances to the group, and there are multiple auto scaling signals that you can use. So here last time we used HTTP load balancing utilization, but this time we are using CPU utilization. Now you can combine multiple signals as well, but I'm only doing one, but you can, explore other mechanisms for auto scaling as well. So I'll cancel out of this one and go here. So this is one thing that I wanted to clarify, which is different. And then again, another set of variables that I have mentioned here, the auto healing initial delay seconds, I'm using 60, so that, the Apache server is installed and up and running in the initial 60 seconds. Then only the health checks will start and the traffic will start coming into the node. Target size I have chosen 2, but you can choose 3 just like I did last time. Max surge is 1, maximum unavailable is 1, but you can, increase it, decrease it, all these numbers you can play with. And again, here I'm assuming that you are familiar with the concepts. I'm just demonstrating here how you can automate the entire process. So I'll not go through all the variables here, but again, the output section here, I'm referencing the MIG ID and the instance group ID, so that you can reference this in the other sections of your resources. So this is the manage instance group, and now let me come to the load balancer. So last time, if you remember, I went through the load balancing concepts and I talked about the various components involved in a load balancer. So basically there's a forwarding rule, there's HTTPS proxy, and if it's a HTTP proxy, you assign a SSL certificate to it. There's a URL map, and there's a backend service, right? And here, if you look at this particular module, we are defining all those components here. So basically there's a health check which will make sure that the backends are healthy, then only the request will go to them. Then we are defining a backend service, right? And then we are defining an URL map, and we are defining a proxy, and this is HTTPS proxy, and then a forwarding rule and SSL certificate, which will be used with the proxy here, right? So each and every component, 1, 2, 3, 4, 5 that we are seeing here, you are able to see all of them here, right? You can dive deeper into each and every thing here, but sharing this code with you, and this is also updated on GitHub. I'll share the link of the GitHub in the description of this particular video. So do check that out if you want to replicate it and all. But the idea behind this is you are able to see all these parameters that I'm tweaking, how I am referencing the SSL certificates, right? And how I'm creating them in the first place, referencing them, and how I'm using the HTTPS proxy in my forwarding rule, so that whenever a request comes to the load balancer, it gets routed to the proxy, and then to the URL map, and then to the backend service. And this is where we are referencing the MIG or managed instance groups. So that's the load balancer. And the final one is storage bucket. Now this one I didn't use the last time, because last time I just installed a plain simple HTTP server, and this is what the response was from the server. But this time I just wanted to show you how in production, if you have some files and you wanted to use them as your static files, how you can do that. So what I'm doing here is I'm creating a bucket, and then I'm then uploading the files, which is a simple HTML file and CSS file, into the bucket. So that's what I'm doing here. Now, last time I used Star Wars as the theme for my demo. This time I'm using Interstellar because again, I'm a big fan of Interstellar as well. So, this is the HTML file and this is the CSS file. Very simple. Before I dive any further, so this was the modules and these are the files. And then this is the main section where I'm using those modules, right? So let's dive deeper into them. And I'll start with the startup script.tpl. And here you can see that these two commands are very similar to the last time that I did. And the additional thing that I'm doing is I'm creating a var HTML folder, and then I'm copying the files from the bucket that I will create using this module, and then I'm copying them to here so that Apache will be able to reference them and then give us the response. So that's the idea here. That's why I created this particular module. Let me wrap up the some other sections like provider.tf. So here what I'm doing is I'm using the Google provider and Google beta provider, and here the backend that I'm using is a GCS backend, and I've already created a bucket to store the state of this particular code. Now, if you want, you can do it locally, but in this particular demo, I'll use the backend as GCS. Now, I'm using Google Cloud for this particular demo. Now, if you are someone who like AWS or Azure, you can replicate this entire thing on AWS Azure, and you will have to make these changes to Azure or to S3, depending on which particular cloud provider that you use, and you have to use the required providers. But I'm just giving you an idea of what you can do, right? So that's the provider. Now let me go to the main section, which is the crux of this entire Terraform code. So starting with, last time I just created the load balancer and it automatically assigned the IP, but this time I am creating an IP so that it's very certain that which IP I'm getting, and then I can add that IP to the A record that I am creating here. So let me create the IP this time using a resource. Then here I'm creating a network, auto mode network. Last time we created through console. And I'm creating a cloud NAT so that the request can go to the outside world. Now, one thing that I didn't mention last time, which was the instances that I used last time, they had an external IP. So they were able to go back to the internet and then download the Apache package or any package, right? But I didn't create the cloud NAT, and they were able to directly go to the internet and then download because they had external IP attached to them. But this time I'm creating private IPs, instances with private IP, because that's what the best practice is. And in order for those IPs to communicate to the outside world, you need something like a cloud NAT. So that's what I'm doing here. I'm creating a cloud NAT and I'm defining a router here, which we attach to the cloud NAT. And I'm making sure all the egress to 0.0.0.0/0 goes through the NAT, right? And that's what I'm defining in this particular firewall here. Right? And that's why I'm creating that particular router and the cloud NAT here. Now, in this particular demo, I am only creating the instances in US Central and Europe region, but in the previous demo, I created in Asia region as well. So cloud NAT, you have to create per region. So that's what I have done here. This one is for EU and this one is for US. Now you can say that, okay, I can make this code much better by using a for loop, but you can do that, and you can use a for each loop, and then maybe in a list you can add the cloud NAT parameters, and you can then follow the try principles and then automate this section rather than repeating these 2 times. You can do that. Maybe I'll add that in the GitHub repo as well, but yeah, that is one thing that I've repeated here just to make sure that I'm being a little bit granular and it's easier for me to explain the code. But you can use something like a for each loop and then do that as well. Now, interesting thing is, ideally we try to make these sections separate for each component, but I've included everything in a single file. But feel free to modify this entire code and then maybe create separate file for network, separate file for instance template, for load balancer, etc. But I am just using one file, main.tf, which is not a good practice, but you can distribute these files as per your need. But I've included resources section and the module section in the same file. Ideally, we don't do that, but just to explain the code, I've done that. Then I'm using the module here for firewall, and this is the important section. I'm referencing the module listed over here, and then I'm just passing all the variables through this variable section that I have mentioned here. So that's the firewall. I'll not dive too much into the firewall because this is straightforward. Then this is important one, instance template. And one thing you can see here is the startup script, and I'm using template file here, and you will use a lot of template file if you are using with startup scripts. And basically what I'm doing is I'm just referring this bash script and then using that as the startup script using template file. The next one is managed instance group. Now again, I've created two managed instance group, one for US and one for EU. And then I'm passing all these parameters through the variable section. And then all these parameters are being used in this module over here. So again, you can make this a for loop and then make a list of variables or a map, etc. But I have repeated this code for simplicity. Now the other section is load balancer, and I'm using the load balancer module over here and then passing in all the parameters. One thing to note here is the HTTPS proxy name and the SSL certificate that I'm creating is also getting passed. And then the storage bucket, and finally the A record that I'm creating. Now all these variables are defined in the variable section here, and the ones that I want to tweak is defined here. Now, as I mentioned, this is based on Interstellar theme, and let me remove this testing from here. So the bucket name is Miller's Planet, the app name is Interstellar, and similarly, I think the network I'll change as well, and I'll name the network as Interstellar as well. So yes. Okay, so I know I went through this code too quickly, but again, I'm assuming that you already have grasped the basics of Terraform, so it will be easier for you to understand what I'm doing here. The idea is to just show you how you can use Terraform to build something complex, all right? And here you can see that's what we are doing here. So let's go ahead and then run this code. Now, one thing is I have already, pushed this code to GitHub. So, if you go to this GitHub repo, real world DevOps project, and then one-global web application, you can see the entire code over here. And you can, whatever I'm doing in this particular demo, you will be able to replicate it and then, follow along. So make sure to change these variables, the backend bucket name, init plan apply, and destroy if you want to destroy. So you can follow this entire thing based on this readme that I have provided over here. So let's do a Terraform init, and this will create this .terraform, and all the modules will be copied here, the providers, etc. Right? And the lock.htcl will be created, and let me do Terraform plan, and so basically this is acquiring state lock. Now this would have been in local, it would have been easier, it wouldn't go to GCS and then acquire the lock, etc. But you can see we have 25 resources to add, and you can go to all these resources and then see for yourself what this is creating. But let me quickly show you what this is doing. and this is not, I the I'm not able to scroll all the way to the up. So what I'll do is I'll do a terraform.out so that you can see the output in a file. Okay, so this is running, it ran fine, and let's go to this particular thing over here. So again, it's like 622 683 lines that were outputted, and here it was like so it will create 25 resources. And since we are running this for the first time, 0 to change, 0 to destroy. And if you go here, you will be able to see that it's creating a global address, which is the external IP. It's creating a network with auto mode, which will automatically create all the subnets. It's creating a router for EU, for US Central. It's creating a NAT for US, for EU, and these will be the names. It's creating a DNS record. It's creating a bunch of firewalls over here, right, for HTTP server and all the egress traffic, instance template, and this is what the startup script will look like. Then it is creating the the backend for the load balancer. It's creating the forwarding rule, the health check, the certificates, the proxy, the URL map, the instance group, auto scaling, etc. So you can take a deeper dive into this output, but this is what the output will look like. So if I go back to my shell here again, and let me do a Terraform apply, and let me type yes. And what this will do is it will go through the entire code and then just apply the resources. So as you can see, it has created the bucket, it has uploaded the files. So let me go to the Google Cloud Console and go to cloud storage, buckets, and Miller's Planet. As you can see, this was just created now, and you can see the contents of the index.html and the CSS. So uh, yeah, it will take some time for this to run. It will take close to 8 to 10 minutes. So let's resume back, and if you are repeating this alongside me, go ahead, grab a cup of coffee, and then we'll get back in a short period of time. Okay, there we have it. So the apply is complete. Now the output that you see here is resources 4 added, 2 changed, 0 destroyed. Ideally it should be 25 added, 0 changed, 0 destroyed. But let me go through what happened. So basically this was running. So I got this error creating backend service, and basically it was not ready. So it would be good if I had added some kind of dependency, etc., which I didn't. So that's why it failed here. But most of the things with Terraform, if you just do a Terraform apply again, right, things work fine, because here it was just that the health check was not ready. That's why it was not being used by the backend service, or it was not in a situation or in a condition to be used by the backend. So that's why it failed here. It's released the state, but when I ran Terraform apply again, all the other resources that were remaining, they went ahead and then created. But it's a high chance that if you run it, it will run one single shot. But there's just one thing, and I'll update the code as well, so that I add the proper dependencies, so that you don't face this error, and it runs without any issues in a single go. So that's it. And now these are some of the outputs that I am getting here. So for example, if I go in the output section over here, these are the things that I've mentioned in my outputs, and that is what you are seeing over here. So let's go and verify the resources. So we already verified the cloud storage. Let's go to load balancer, or let me start from instance template. So the name is Interstellar. So this is the instance group, and we can see all these configurations here. Now it's already being used by these two MIGs. So let me go to the instance groups, and let's again search for Interstellar. And we can see these two instances are up, and auto scaling is target CPU utilization. And let's go here, and they are healthy as well, which is great, right? So this is up, and you can see all the configurations that we mentioned in our Terraform. So for example, the auto scaling is based on CPU, initialization period is 60 seconds, etc., right? So that's good, and the instances are healthy, so that's again good news. It means that our starter script ran fine. And if I quickly show you the health check, it will be like on port 80. So that's where our web server is running. So all in all, awesome till here. Now if you want to go one step further, what you can do is you can SSH into this instance and see for yourself what has happened, and all the other things like whether Apache 2 was installed or not, etc. So let me quickly show you that as well. So if I quickly type sudo systemctl status Apache 2, you can see that it's running. And if I go to cd var html, and if I just cat out the index html and main css, you'll see that everything was copied successfully from the GCS bucket. So that's good. And if I quickly do a curl on localhost 80, you'll see that there's a response coming back. So that's good. Let's close this, and now let's move to our load balancer. So load balancer Interstellar is the one that we created this time, and you can see that the two backends are there. Two of two instances are healthy, and it is using the health check, and this is the IP port 443, which is awesome. And then let's go to the certificate. Now if you have watched the last video, I would have mentioned about the certificate, how it works. So basically, if you see this domain name, you have to make sure that this domain name is added to your managed zone, right? So if I go to the zone, and if I go to the A record, it should be here, right? And that's the way that Google in the backend verifies the domain name and issues the certificate. So if you haven't done this step in your Terraform code as well, this certificate provisioning will fail, right? Now this thing will take some time. In some cases it takes hours, but I am hoping that it should be up and running in the next 15 to 20 minutes. So let's give this some time. But overall, the load balancer is up, the settings are looking good, the configurations are good. And if I go to monitoring, you can see that last time I have already shown you this, that I have the two managed instance groups. Now I haven't hit them with any traffic as of yet, but the configuration is looking good. So let's wait, and let's wait for this certificate to be provisioned. And we don't have to wait, right? So it got provisioned. That's a good news. Now let's go ahead and then try to hit this website. Now you'll not be able to get the response as soon as this certificate is provisioned. It takes another 5 to 10 minutes for the certificate to propagate throughout the entire internet. So let's give this some time, again 5 minutes, but the certificate has provisioned successfully. So that's good news. And now let's wait for another 5 minutes, and then we'll get back and then refresh this page, and hopefully this should work. Okay, so after waiting a couple of seconds, if I just hit refresh, you can see that, our website is up. So it proudly says a very famous dialogue from Interstellar. It says, "Mankind was born on Earth. It was never meant to die here." This application has traveled through a wormhole of network traffic to reach you thanks to Google Cloud. And this means the demo or this particular thing is working flawlessly with all the bunch of code changes that we have done in Terraform. So from the load balancer, from the managed instance groups to the network, the health checks, etc., right? So all these things are coming together and then serving you this particular awesome website that we just built. Right now, if you want to follow along, you can go here and then clone this repo, run in your particular environment. There are some few prerequisites that you should have a domain name available if you want to use the HTTPS configuration, but you can use the HTTP as well. In that case, you will have to change a couple of things, like you will have to use the HTTP proxy rather than the HTTPS proxy over here. And in the forwarding rule, you will have to use port 80 rather than port 443. So these are the two configurations that you have to make if you don't want to use the SSL certificate. But apart from that, things should work fine if you don't want to use the certificate. But I just wanted to make sure that I give as close to production grade setup. Now, one thing I repeated in the previous video as well, that I'm using the Google Compute Engine as the compute, but you can use Kubernetes or GKE as well, Cloud Run, Cloud Function as well for your particular use case. But let me know if you want to see Terraform code for implementing the same thing using GKE. I can do that as well, but I will highly recommend you to first give the shot by implementing this entire thing using Google Kubernetes engine. And if you face any issues, let me know in the comment section, or you can feel free to reach out to me on LinkedIn, and then I'll try to reply as soon as possible based on the bandwidth. But yeah, feel free to do that experiment. But I hope you like this video. In the next video, what we'll do is we will take this entire code and then build a CI/CD pipeline so that the commands that we ran today, which was apply, plan, and init, it automatically runs whenever we commit this code to GitHub, and then it automatically gets deployed. So that's what true DevOps is: automating things and giving the time back for some more innovation, etc. So stay tuned for that video. But if you like this video, feel free to share this with your friends who are interested in DevOps, cloud in general, and hit the thumbs up button, that's the like button, and subscribe to this channel if you want to see more amazing videos like this, and keep exploring. Stay tuned for the next video. Until then, you get to live, make the most out of it. Thanks for watching.